students. Now we will discuss how to solve a Rastrigin optimization problem using grid search algorithm. Okay. So let us go directly. So we will import the required function available in this path. So first we will write the syntax for grid search function. So now you understood that you have to define all these 5 parameters. So let us define one by one. This is the objective function we have to implement. You can see the second function, sigma I running from 1 to d xi square minus 10 cos 2 pi x I plus 10. Okay, you can specify the dimensionality. Let us say for simplicity I am taking the dimensionality as 3. You have to find the optimum, that is minimum value. First we will find out the minimum value in between this range minus 5.2 to plus 5.2. So first we will define the step size as a column vector. So I already implemented, so I am directly writing here for you. This is the step size, and then define the lower range. It is also a column vector. So here the lower range is minus 5.2. So you have to repeat this 3 times because the d is equal to 3, and then the upper range as you have to search in between minus 5.2 5.2. So I have already defined like this. So final thing is you have to implement the sphere function. So you can see the sphere function. So it is implemented as xi square minus 10 cos 2 pi x plus 10. So I already told you x is a vector here. So automatically your grid search algorithm, it will compute a vector x and it will pass to this function, and this function will be evaluated at that x. So 10 into length x means this one, this constant, okay, plus sum of x to the power of 2 minus 10 into cos 2 pi x. So all the operations are done on element by element basis. That is why we are getting a simplified, a single line statements. Okay. So once you have written this, you can start executing. So finally you got the minimum value at 0.3 for sphere function. You can also execute step by step. And you want to find out the maximum value, that also you can find out. The only thing is just you have to change the function max. Okay, this argument, the last argument, you have to change. So you can see this here, you have typed min. Instead of min you can type max, and then you can get the output. Control S. So now if you execute again, so you got the maximum value at 4.7, 4.7, 4.7 at this value. So in this way you can solve the problem. If you want to change the range also, you can change. Say for example I want to find out within this range. Within this range you want to find out means that also is possible. So that means here you have to change the lower range. You can change the lower range, you can change the upper range. So you can specify different upper ranges for different variables. So I have changed something like this. So there is no rule. So you can fix the different ranges for different variables and see how the output look like. So, you can see the maximum value you are getting is 126. So, here we have changed the range for different variables. So, please, this is the range I have taken minus 6.2, minus 5, 4.2, minus 5.2, different lower ranges for 3 variables and different high ranges for 3 different variables 3.2, 6.2, 5.2, and see what is the value you are getting. So, now you are getting a different value. So, this is the maximum value you are getting at this position or solution. Okay. Similarly, for minimum value, this is the minimum value you are getting at this position, at this solution 0.4, 0.2, 0.3. So, in this way you can get either minimum value or maximum value by changing the type here. By passing different arguments you can get outputs. Okay, students. So, you can execute and you can analyze the output. You can modify the different variables and see how the output is changing. Thank you, students.